Good morning. So yesterday we have seen the definition of the zone plate. Okay. So now let us see the complete view of the zone plate with the diagrammatical explanation. Okay. So let us consider a zone and in a section of a zone that is XY. Okay. Let us consider the XY as a section of zone. So now that section of zone what we considered is perpendicular to the plane of the paper. So as shown in the figure, as shown in this figure. So let us consider, okay, let us consider S. S is a point source of the monochromatic light. Okay, let S is a point source of the monochromatic light giving out spherical waves. Okay, so the spherical waves are produced from this. Okay, so the spherical waves consists of the wavelength lambda, and this p is denotes the position of the screen of a bright image. Okay, position of the screen of a bright image. Now we consider, yesterday we have seen the number of zones like m1 zone, m2 zone, and m3 zone, and mn zones. Okay, so O be the center of the zone. Okay, let O be the center of the zone, and the radius will be, suppose if O is the center of the zone and M1 is the first zone, so the distance between this O and M will be R1. So if O is the center position and M2 is there, then the radius will be R2. Okay, so these are the radius of the first and second and nth period, nth half period zones. Okay, let A be the distance from this point to this point. Okay, let A be the distance from S to O. Okay, and B be the distance between O to P. So now the difference. Okay, so the position of the screen will be an increasing path difference with the lambda by 2. It follows the path difference of lambda by 2. Now see the mathematical calculation. If we want to calculate the S1, okay, if we want to calculate the S2P, that is M1 zone, okay, what the formula? S M1 plus M1P is equal to this term, entire SM1 plus M1P is equal to SO plus OP plus lambda by 2. Okay, so SO is nothing but small a and OP is nothing but small b plus lambda by 2. So then for the first zone, this is the calculation part. For the second zone, it will be 2 lambda by 2. Okay, for the nth zone, it is n lambda by 2. Okay, from the figure we can say that, okay, the SMN value, okay, this value, the SMN value. So the SMN will be equal to SO plus OMN. Okay, SMN is equal to SO plus OMN. So SMN whole square is equal to SO square plus OM square. So SO, you know that A and OM is R. Okay, the distance between the center to the zone. So Mn square is equal to A square plus R square. Okay, so Sm is equal to under root A square plus R square. Okay, then coming to the next part, remove the common of A square. Okay, so we'll get this term, right? So if you calculate this part or 1 by 2 inside, what will get? 1 plus R square by 2A square. Okay, so then if we multiply A into inside of the brackets, what will appear? A plus n square R square by 2A. Okay, so this is SMN value. Suppose if you want to take the MNP value, we'll get B plus R square by 2B. Okay, why A and B represents? SO is nothing but O value and OP is nothing but B value. So substitute now equations 2 and 3 in the previous equation 1, that is nth equation. So this will be the term what we enclosed there, right? Next, if we cancel all the terms A and B, okay, then 2R square by 2AB. So both the by 2 gets cancelled. So the remaining term after removing the common of R square will get this term. Okay, so if we remove the sign convention, that is placing plus as minus and minus as plus, what will get? Minus 1 by A plus 1 by B is equal to n lambda. So finally we will get this term, and if you assume Fn is equal to r square by n lambda. Okay, the equation will be 1 by b minus 1 by a is equal to 1 by Fn. So this is almost equal to the convergence length. Okay, length formula, it is almost equal to the length formula, that is 1 minus v is by 1 by v minus 1 by v is u is equal to 1 by f. So hence the zone plate, this shows that the zone plate behaves like a convergent lens. Okay.